Okay, here we go. Hi everyone. It's Nick again with the live stream create and hang doohickey that we're calling this thingamabob. Hi, welcome back. So today I am going to be switching gears a little bit. Let me kind of just get myself oriented here. So essentially what I'm going to be doing today is one, I'm going to get you up to date on where we were with the... Oh my gosh, my music is so loud. Sorry. I'm just going to tweak the audio levels a little bit. There we go. It was coming in loud over here and probably okay over there, but had to make a little adjustment. Anyway, want to make a couple updates. So last project I was working on, it was this sort of fume extraction system, specifically for my 3D printing area. I'm happy to say that project is going very well. I'm actually 3D printing the last few parts I need, and I'm hoping to create another video showing you when it's all done, sort of like the before and after area. I am no longer working on that project here for the live stream because it felt kind of clunky to like show you what I was doing while I was trying to learn it at the same time with software that, while not bad in any sense, is not like super fleshed out in terms of user experience. Works very well, and it just felt a little weird to keep showing that on screen until I got up to date, which I'm happy to say I have a better understanding of. So I'm not going to be showing the fume extraction system on the live stream. Instead, what I'm going to be doing is something a little bit different. In fact, what I'll do in a second is I'll actually show you like where... Actually, I'll show you in a different video where that is. But we're switching gears. We're still doing some 3D printing stuff, but I want to come up with a shelving system. So if you look behind me, behind the curtain, I have this desk over here. It is absolutely cluttered with stuff. And part of the reason for that is that most of this was actually by the 3D printing area that I have, but the whole reason for me cleaning that up, which again, there'll be another video, hopefully sometime in the future, is the workspace was not well configured for what I needed. Everything was on top of one another. The shelving wasn't organized. It was tough to get what I needed. And if you've ever been in, like, you want to like make something, but you have these obstacles in your way that just stop you from sitting down and going at it, then that just makes it a lot harder to do that. So right now I have all these art supplies. Like, I want to learn how to draw. I want to learn how to like paint stuff and do minis and all these other crazy things. But when you have a messy workstation like that, one, it's going to stop you from doing stuff because you got to clean it up. And if you don't have a dedicated space for things, then you're going to have to clean it off each time. It's going to be a thing. I want to keep this as clear as possible. So this part of the table over here actually comes up and down for when I need to draw. And there's a side table over here, which is slightly off screen. And what I want to do is convert that to a shelving sort of area. And we're going to do that through 3D printing. But there's a couple parameters we're going to set. So I don't know how long... itchy ear, sorry. I don't know how long that part of the project is going to last, per se, because there's a few things that I learned from the previous project that we need to be aware of. So this might just be a brainstorming thing. There might be a little bit of CAD work going on. We'll see where the project goes. Maybe this will be 45 minutes. I have no idea how long this is going to take, but we have a few parameters that we need to pay attention to while we're building this unit. So that's what we're going to be working on. So let's go ahead and jump in. So I've got GIMP open over here, and you've already seen me waving this thing around. This is my Wacom pen. I actually have my tablet hooked up because, as you saw in the previous videos, drawing with a mouse is an absolute abysmal horror. And I don't use that term lightly. To those of you who actually do draw with a mouse, my hat goes off to you. Not right now, because my hair is an absolute mess, even for my standards. And yeah, it's very, very tough. I don't recommend it. If you can, get yourself a tablet. It doesn't need to be a Wacom one. I'm trying to, so that's my tablet. It doesn't need to be a Wacom one. Anything that, you know, will take an input is totally fine. We've used... what have we used? No, Intuos is from Wacom. I'm blanking on the company we use, but Huion. We've used Huion tablets. They're a little bit on the cheaper side, so they may not hold up long term. But if you want to just get into drawing and that kind of stuff, it's a great place to start without throwing in a lot of cash. And they've held up pretty well so far. but I happen to have one because I use it for sculpting, and I've used it for a couple of things. But because it's so hard to draw with a mouse, I am making use of it today. So we're going to just create a blank template here. Just make sure this is working. Awesome. Oh, do I not have my map to undo button here? I'm actually going to go into my control panel for a second. Pen and touch. No, I need the Wacom stuff. Basically, what I want to do is I could hit Control-Z on my keyboard to hit undo, but I think it's going to be a lot more efficient if I actually map it to one of the mouse clicks here. So it's just going to be a lot faster. So we're going to go over, because just out of curiosity, what are these mapped to right now? They mapped to anything? I got nothing. It's probably not integrated with GIMP entirely. So let's go to Wacom tablet properties. Tablet driver is not found. Ugh, I probably need to reinstall it. All right, so we'll just use it as is then. That's fine. I'll have to make do with the keyboard. All right, blast you, Wacom. Again, I'm using a slightly older operating system, if you couldn't tell. I really do need to upgrade it. We will just say, fine. All right, so what are the parameters we need for this project? Okay, so hello. Oh, because I don't have the tablet software installed, which I checked before I started this. This is basically acting as a mouse, so it's not tracking correctly through the screen, so that's fine. But basically, let me do this in black here. All right, so basically, number one, this is still coming out hard. All right, well, it's better than nothing. We're going to roll with it. So number one, we need to be aware of the area that we're going to work in. Wow, that really doesn't do my handwriting justice. I know it's scratchy and scribbly, but that's even worse. So basically, we have an area constraint. Oh, don't judge me too badly. This looks horrible. Okay. Can I at least, you know, do that? Yeah, it's a little bit easier, but not much. Man, I wish I checked this before I started, but we're not stopping. We're not stopping. All right, so we have an area constraint. So the actual table that I have, so it's that little area over here. I know the dimensions are 11 and 9. 9/16 and a little bit more. This is actually something I learned from when I worked construction for a very brief period of time. I worked at a summer camp, and I worked with a construction guy to repair this deck. There were 3 beams, and the center beam had completely collapsed due to weather damage, so the whole deck was like forming a bowl. It was quite an interesting thing. So I actually ended up working with him because I was on the maintenance crew for a period of time, and he would take the measurements, but sometimes nothing's perfectly accurate, and he had a tape measure that wasn't quite, wasn't super fine. So sometimes the measurements would be just a little bit more and a little bit less. So he would basically add these plus or minuses to say it was just a little bit less or a little bit more than the actual measurement, just to give himself a little bit room of error there. He had some other notes and ways to denote it, but I can't remember what they were. But I'm just saying it's a little bit more than the 9/16. So it's 11 and 9/16, and the long way here is 23 and 5/8, and a little nubbin again. In terms of thickness, I might as well have used a mouse for doing that. All right, so this dimension over here, this is 3/4. And that's actually right on the money. And this is all in inches. So we're going to have to convert that to millimeters in a little bit. That's totally fine. So we have a certain area to work within. 2, I need to make sure that whatever I print, we have a limited printing. We have a limited printing constraints. Or I should say area. So I have a Prusa i3 Mark II, i3 Mark II S, something like that, and it has a limited build volume. So in other words, we can't just say, okay, we're going to make it this tall and this wide and call it done. you saw that in my other project, I had to be very careful about the dimensions of everything I was going to print with. And then there might be further complications if we, say, add a brim or a raft and whatnot, because then it's going to need more area. So I can't quite remember what the exact dimensions are. So I was hoping to add in a shape here so I could actually double check that. Oh, is it going to really make me do that? All right. We're going to go to Blender for a second. I just need a cube. Give me a cube, sir. It's probably going to come out super small, but that's okay. We'll call it untitled. I'm going to delete this right after I'm done. All right. Where did... I need to clean my desktop again. Where did it go? Untitled. Bop. Yeah, it's super small. That's okay. We're just going to scale it up ridiculously. Nope, wrong way. All right, cool. So just want to double check. All right, so right about there. There. And hut. Boop. Okay, so I think this is 200 millimeters. Oh, that's the wrong dimension. Oh no, I must have moved it. That's okay. Boop. So we have about, what is this here? So we have about, is this X? So what is this, 250, I'm betting? No, don't scale it up all together. Oh, I probably have to turn that off. Okay, cool. So what is this, 250, 200, and 200. Give or take. That's what I'm going to assume. Or it's going to be close enough. All right, so we know what that is. So it's X, Y, and Z. How is it? Actually, how are the X, Y, and Z coordinates defined? Which is very important when you're working with 3D software, because while this I know for a fact is Z, some other programs might call this X. So gotta pay attention to that. Let's move this over here. And nope, I actually don't need you anymore. You can take a hike. Take a hike, program. Ugh, I hate not having the tablet software installed. All right, so we have a limited printing area. We have Z, Y, oh Lord, Y, O, Y, and X. Here, what am I looking for here? Okay, I'm actually going to put this on my other screen here. Make sure that is correct. Yep, that's Z, X, and Y. Okay, got them right. So X is 250 millimeters. Y and Z are 200. So whatever we build, it either has to fit within that area, which it's more than likely not going to, or, which we're probably going to have to, in this case, make something that is modular so that we can print it and then put it together. However, one thing I also want to pay attention to is material. Material use. So the less PLA I can use, the better. Because that way I can basically print it faster. So the less material I can use, I think that'll be to my benefit. And one thing that I know for a fact what probably would be a bad idea is printing out an entire shelf out of PLA. Because one, if I'm gonna print the whole shelving unit across here, this is already going to be more than my printer can handle in either direction, which means I would have to create a shelf, print it in two parts, somehow interlock it, and then somehow bind it together. But then I'm going to have a weak point right in the middle, and that's going to maybe force it to break depending on what I put on there. Granted, it's mostly going to be paintbrushes and pencils and all that kind of stuff. So I kind of doubt that it's going to give. But at the same time, that's going to use up more material. So we should probably also put a note on what's going on the shelf. I wish I installed the driver software. Oh, this is driving me crazy. But we're already 15 minutes in. We're gonna grin and bear it. Okay. I love how it looks like. You know how like you're in preschool and your motor skills are still like getting together. It's kind of like I took a crayon. I was just like. Oh well, at least I can read it, sort of. All right, so these are our project. The P's going off the top there. So these are our project constraints. Should I just write in cursive? Is that going to be easier? Ah! Boop, boop, boop. So these are our project constraints here. And that's what we're going to have to adhere to. So with that in mind, I think it makes sense to make the framework out of PLA. Because that way, it's going to be less plastic, it's going to print faster, and it's going to be easier to put together. I also need to decide how tall I actually want to make this, because I have a lot of real estate over here I can potentially use. I'm going to have to move some from the sorry, talking takes words. I'm going to have to use some, I might have to move some picture frames over here, but I've got another wall for that. So I'm thinking we may want to make this thing fairly tall. So maybe we should come up with some areas too. So those are the constraints. So let's come up with some ideas. Let's say sketch 2, question mark. Let's also save this. Shelf. Not shelf. How would you shelf? I don't know what that is. Shelf. Apparently I don't know how to type either. Okay, so we're hangout projects. We're gonna make a new folder. If I can do that here. Here we are. Let's call this Shelving. We're gonna save this in here. Oh, we just had a cat wander in. Don't you dare. Don't you dare. I just started recording. All right. Staring me down for a second and then went over to my bed. You can have my bed. Just, oh, no, there's, okay. Very temperamental, these felines. Okay. So, we have our sort of area here. I'm going to 100% cheat and use the straight method here just for clarity. I probably could do this with a mouse, but I got the tablet out now, even if it's not working correctly. So I got this long space over here. It's a little exaggerated, but what are you going to do? So I've got this long area here. So I definitely think the framework should be printed in PLA. But I have a bunch of cardboard, and cardboard is pretty sturdy, particularly if you reinforce it with something. So I'm thinking that for the actual shelving pieces that go across here, we can just use cardboard. You know, obviously if you're doing something a little bit more intense, then, you know, you could, if you got a wood shop or something, or you have access to wood, you can just go ahead and, you know, do that. However, I'm going to use the materials that I have on hand to lower the cost. So I think we're going to end up using cardboard. So that means we need to come up with some sort of system that will allow me to kind of like slide in these cardboard pieces. So I can actually erase this because I have the measurements digitally now. So we've got this sort of area here. I do think for, let me change the cooler. So what I'm thinking for the first part is one of the dangers that I can foresee happening is that if I just have, you know, some sort of shelving thing that's just on the table, one, because I have cats. Yeah, I'm looking at you. There's a danger that they may get on the table, knock things around, and then that's gonna, you know, go off and it's gonna clatter and fall and things will break and bad times will be had. And we don't need no bad times around here. So what I'm thinking of doing is having some sort of setup where we've got these little clamps that will essentially slide onto the table. So if we look at this from the side, essentially we're going to have a unit here, and then this piece will slide onto the table, right? You know, we can make it however thick we need it to be. You know, and that goes over there. So something that I can put onto the table itself, and I can put them one here. We'll say like another one goes over yonder. Again, I'm kind of overdoing the size a little bit just so this is easier to see. You know, and then that'll go over there. So that way, once it's interconnected, you can't actually slide it backwards or forwards. I may actually want to... If I make these correctly, I could potentially also structure them so that they go sideways as well. Oh, that's a little too tall for me. Alright, it's exaggerated. Just bear with me here. So that way I can't pull the shelf off this way. There is a danger that I can push the shelf that way, but I have a big like armoire right over here, so it will stop it from doing that. So put that there, put that there. Again, it's over exaggerated, but that's okay. Way too big. That's alright. Or if I'm smart, I could devise corner pieces. Would that do the job though? So if I have, say, a corner of the table here, and I have a thing that goes on like that. So if we look at this in 3D, essentially it would look something like... Trying to picture this in 3 dimensions here. Something like that. Question mark? So basically the side of the table would go over here. So that way it would prevent it from sliding both back into the side. That might actually be pretty good. If I can get that to work. Because the thing is, this needs to all connect together somehow. Otherwise, it won't matter where I put these pieces. So I got to think here. And this is very hard from a poor wee brain. Just going to get rid of all this junk. So I do have these chrome shelves that I occasionally use. And the way that they're put together is there's basically 4 posts. And you put these black plastic pieces on there. A shelf is lowered down, and then through the pressure of gravity, it basically gets stuck. Because these are like, they're not perfectly straight. They're kind of trapezoidal slightly. So that way it will create a very firm connection with the metal shelving. I'm sure you guys have all seen them. It's like the basic like chrome shelving you see now and again. So the problem is with this design is there's nothing connecting all the pieces together. And I think that's where we're going to run into a problem. There's no way that I'm going to be able to connect a piece this long. This way, more than likely. Unless I create some sort of attachment. Question mark. Alright, so let me erase this. Yeah, this might be the whole live stream, just me trying to like work with my foggy, dumb brain, trying to like work this through. But it's better I do this here than trying to figure it out, or like just throwing something together, throwing it on the printer, wasting materials, money, and time. Like, if there's anything that you don't want to do is waste your time, especially, but also your money and your resources. That's just bad mojo all around. Alright, so we'll kind of come back to the idea for a corner piece in a little bit. So I don't know. I'm just gonna make a note of it. I can't even remember how I drew it. We'll just extend this out. That's a horrible drawing. It's very hard here. I'm just gonna write corner. That doesn't say anything, Nick. Corner, question mark. All right, so I'm gonna actually open up a new page really quickly. So let's draw this from the side, just to make this a little bit easier. Cool. And the reason that I'm actually drawing this in orange is one, so it's easier to see, but I actually have a lot of orange filament, so makes sense. So let's see here. I'm gonna have, we definitely need 4 posts. That's a guarantee. However tall they are, you know, whatever that turns out to be, it's gonna be some X amount of distance. So we're gonna have 4 posts here. Now, in order to keep them together, how do we do that? Do we have something on specific levels that comes across? And then we have like notches for the cardboard so I can change the height as I want. So in other words, like have a fixed shelf increment every so often to make it more rigid, and then we can have the bottom pieces. That kind of makes sense. I say. So then the question is, how do I do that? Because I don't have enough shelving units to copy that idea with the chrome shelving at all. So let's look at perhaps I'm going to open up another sketch. Sketch 222, number 2. So let's say we've got 2 of the smaller pieces here. Now, obviously, I can create some sort of bracing unit across that away, which is totally fine. Question is, how do I actually do it? Do I have, say, if this is one piece here, and I'm assuming they're going to be square because they're going to be a lot easier to print than a cylindrical piece, do I have, say, something that goes all the way through and then clamps down on the other side? I don't want to go too crazy and fancy with screws. I just need a way to actually secure this. And I'm going to be lazy and slouch for a bit because I've been sitting up straight all day. Don't yell at me. I know posture is important, but my back hurts. Let's see here. Well, maybe we can look at... Maybe I can have pieces that drop in together. So if I have, say, let's say we have a square piece, right? Maybe I can have a section that sticks out that's got a particular shape on it. And I can always print this part separately and then glue it in later. So maybe then I'll have like a little slot here, for example, that will be placed inward and then pushed down. That's a design that I've seen before. Essentially, if you ever see that cheap shelving bracket, so generally what you'll see is like for really like simple shelving, there'll be like a bracket and then it will have a larger hole and then a slightly... It'll have a larger area and then a slightly large area, slightly smaller round area. And basically that's designed so that a rounded piece can slip in and then slide down to a tighter fit. So I could do it that way. So that's one region. Is there a simpler way that we can do it? Because if I just have this and then like a little recess that's just attached, then that's not going to hold it together. That's just going to be, you know, a round part will be resting on there. That doesn't make any sense. I mean, the other thing I could do, I want to save the PETG for if anyone needs like a mask or something, because I've been printing those on the side. So I'm trying to save my materials for that. So I've been using the cheaper stuff for my own projects in the meantime. So if I was using the harder stuff, what I could say is if I had PETG, then we could just actually drill into it. Why is that? No, it's not drawing the thing. That's the interesting thing about... so PLA is usually what I print it with, and it's usually what we use at the Digital Art Experience. Digital Arts Experience. However, it's very brittle. It breaks easily, but it's very easy to print with, and when you got to print out a lot of stuff, and they're not being used for, like, tougher pieces, PLA is totally fine. However, PETG is sort of a mixture of ABS and PLA, and it's magical stuff. It's very tough, fairly easy to print with. It does string a little bit if you don't get the temperature settings just right, and you can also like sand it and use hardware on it. PLA will just get destroyed. But I don't know why I went ranted on about that, because I can't really use it in this instance. So let me see if... I'm actually going to go online, see if we can find any example. Oh, so this is what I was talking about. So you see how there's a larger hole up here, and there's a slightly smaller circumference on the bottom, so that way you can drop the shelf into it. So that's kind of what I'm thinking. This looks like we've got a stacked area, but we still got support pieces underneath, so that won't help me. Yeah, let's see if we can find any bit of inspiration. Could do like the 3D printing bracket thing, but I'd rather slide the cardboard in and have it be fixed. Might just go with that idea. Who knows? It's crazy times. Let me see here. I don't know how I feel about this design, because it's like, I'm afraid if I'm trying to reach this stuff up here, then I'm going to stub my toe on the bottom. That's like more than likely what's going to happen with me. I'll increase the music just a smidge. I think it's coming a little bit lower. Alright, that should be fine. Okay, what is this? I think this is... no, don't actually take me there. I just wanted to see a picture. Oh, it's taking me to shopping. Of course it is. And these might be drilled on the side, so they've got support pieces there. I mean, the other thing I could do if I really wanted to keep it simple is I could also come back over here. The other thing I can do is I can print the support pieces with essentially just shelving parts already built into it, and then attach the cardboard down that way. So then, like, every so often, again, this is going to be larger than it actually needs to be, but then, like, have that stepped. So that's another option I could do, and it's probably going to be a lot easier than this method, because I could just print that as one whole piece. Granted, I'll probably have to do it in, like, multiple pieces and have some sort of connector, but that still doesn't help me with actually making a solid, rigid frame. So if I'm going to have a box, right? Essentially, we've got the 4 posts. We've got this one, we got that one, we got that one, and we got that one. But we're missing the connection parts over here to make it more rigid. That's what I need. So let's see if I can get any ideas. My brain is super foggy right now, so I'm sure there's a easy solution, and some of you might be yelling at it through the screen. Who knows? That's kind of similar to the Chrome shelf design. Google, you have not been helpful. You have failed me, Google. How dare you? Yeah, it's all the same. Yeah, basically, if the posts are not separate and they don't have support pieces, the shelving usually acts as the brace, which I do not want to rely on cardboard for that. I think that's a bad call. That's a wall thing. That doesn't help me. And they've got longer pieces over here. Again, I'm not worried about it being so unstructurally sound that my supplies are going to fall off. It's more about just making sure that it can stay up, period. So, I'm thinking maybe what I can do... If I'm going to make that super tall, which I don't know if I am yet, then I probably don't want to have this be too long without a connecting piece down here, because the longer something is, the more leverage it's going to have. Archimedes, I believe that's who it was, said if you give me a lever long enough, I can move the world. I think he was Archimedes. I got to double check. Archimedes. He's a Greek mathematician, for those of you who don't know. I would like to study more of Archimedes, if I can. Plus, he just has an awesome sounding name. Archimedes lever quote. Oh, yeah, it looks like a... Give me a lever and a place to stand, and I will move the earth. Give me a fulcrum, and I shall move the world. It looks like they kind of took a couple different quotes and put it together, but that basically you get the idea. So I'm a little wary about making this super tall without having a piece to support it. So right now, we got to figure out how to connect the two pieces here. Shelving, I think, is not the super crucial one. It's more just about making sure the darn thing will not, like, rock and fall apart. So we're getting there. We've got our constraints. We've got our post idea here for the base. But now we got to figure out how to connect all this hoop-de-la. Let's see here. Let's open up another sketch. I'm saying sketch. There's just another page. So what can we do about that? We're going to keep it simple. We've got two here. I am 100% going to reinstall the drivers for this, because this is driving me cuckoo for Cocoa Puffs right now. Alright. So one thing we could do is during the assembly process is maybe I can actually just put holes here and then have the, or maybe some sort of design that latches in a particular way, and then essentially I can have the part, so another square, so have a square shape, but then either have another part that's extended off of that. So instead of dropping it down and connecting it, I can have it go all the way through. The only question is then how do I secure it? So in fact, the dropping part might be a little bit better. But is that going to be realistic for going the long way? Because this is the short way right now. Maybe I can split the difference here. So maybe what I can do... Oh, my music stopped too. Ah. Actually, maybe I can work something out so it's not so complicated. Because having all these interlocking parts is going to take a lot of manufacturing, and I don't think I have that time. You know, I could do it, no doubt. But I think there's other things I want to do. I think we need to plan this so that it's modular and easy to build and easy to connect, because then there's a problem of actually connecting all the pieces together, because then basically in order to, if I go with this, I'd have to position it in such a way that I actually snap it together. I think we need to do it so there's, while there will be more parts, something that's easier to put together. So I'm actually going to ditch this idea. So I think what I'm going to need to do is still stick with the fixed shelving idea, but let's do it this way. So let's say we got a post here, we got a post here, we got a post here, we got a post here. We will still have connectors on the bottom and across the sides. And then at fixed increments, we will do the same across here. And then have the slots for the cardboard. For the base unit, I'm thinking of coming up with some sort of system so that, for example, let's actually just take a look at this bar right here. So we're going to have the corner post, you know, so we're going to have something that grabs the actual table. All right, so the table would actually be here. We'll have the post go up. We'll have the cuts for the cardboard in however X amount of increments I decide to do that in. However, this bottom piece will actually slot into each other. So I'm actually going to have to break this up into 3 parts. We're going to have the post here with the slots, yada, yada, yada. We're going to have... Oh, maybe I can do it. Interesting, interesting. Maybe what I can do is have the 2 parts interlock. So have this piece here. Bear with me, I have a thought. So this would come down. And then once that is connected, and I can also hot glue this if I want to get like a little bit more rigidity out of it. So once those pieces are connected, they're all snug, they're in the right place, then maybe I can slide on another piece that will slide down and fit over that, if I can get the tolerances right. So then we'll end up with this 3-piece over here. So this is part 1, 2, 3. Ooh, that's a horrible 3. And then that will come to this shape over here. So then the idea being... I got an idea. We're working it out. So let me actually erase a little bit over here. Just gonna redo that a little bit. No, it's the Splishy Splash song. Get out of here. There we go. There's like one song in that track that I really don't like. Okay. So maybe I can have it so that this will actually be another piece. So maybe I should redraw this, but a little bit bigger. Let's get this out. Actually, why don't I just... Nah, I want to see the images. All right, so on part 1, we're going to have the... We probably can make them a corner piece. Yeah, I think we're going to have to do this carefully. Granted, it's going to be made out of cardboard and plastics. I'm not looking for it to hold up the Empire State Building. You know what I mean? So, let's just start with one of the corners. So, we're going to have a square piece here. All right, so this is going to be part 1. It's going to have a little shape that's going to allow it to fit into one of these corner pieces. So, this is part 1. The corner piece itself... Why am I so far away? Let's actually just zoom in here. I mean, for clarity's sake, this should be a little smaller. You know, I'll have a little piece that's just, you know, hanging out, waiting to do something. Then I'll have... Then we'll have the corner piece that we previously discussed. Oh, that's like right on each other right there. Ah, stop it. Blech. All right, there you go. So that will slide into the table. This will have an opening. That will allow that to slot in. This is part 2. All right. So we'll have those pieces. And then what I can do is we can add a... so then once we do that, you're going to get essentially... you know, this piece. Sorry, this drawing is a little off, but that's okay. It's purely for brainstorming. Oh, God, that looks horrible. That's all right. You get the idea. It's beautiful. Erase this a little bit. All right, then we can have a ring come down. So we'll have another blocky piece. With a hole in it. With a, you know what? Let me draw it straight for crying out loud. So we'll have a piece here. Boop, 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 boop. Again, larger than it will actually be. No, stop it. You know, and then we'll have that. Oh. I'm sure, like, all the famous engineers in the world, all, like, you know, the Da Vinci's, the, I'm trying to think of actual engineers. I know famous artists, but, like, all, like, Da Vinci comes to mind because he was, like, an artist, an engineer, and all this kind of stuff. I'm pretty sure, like, every inventor in the world is cringing somewhere right now. Just these horrible, like, I have all this wonderful technology, and I'm drawing out scribbles like a 2-year-old. But that's okay. So anyway, we're going to have another part. We'll slide down. This is part 3. So then we will get this. Again, over-exaggerated. And then this will actually be underneath the table. Underneath this part as well. Because this part's going to be above table. This is going to be below, but this is going to cover up. So it's going to be flush right here is like where the table would be. Like that's the table surface right there. And that's going to line up with the inner part right there. Do. You know, so only a little bit of this is going to even stick out. So then the idea is once that is done, I can go ahead and create another modular piece here. That will basically snap into there. Again, we can use hot glue to solidify it if I really want to. So that will be part 4. And then we'll finally end up with something that hopefully resembles something halfway decent. That. Stop it. So you wouldn't see this. You would see. Nope. Wouldn't see that. You wouldn't see that. Actually, you would see the division part for the where the prints come up. So this would be right there. And then, obviously, this would be below the table, but we'll just draw it for posterity's sake. Maybe I'll just do that in a different color. Hup. All right, you get the idea. So then, basically, it will be this interlocking system. And then what I can do is have that go across in one specific direction. So to keep the shelving as simple as possible, we can have this done on the long stretch. I guess it depends, because the question is, I kind of like this idea because it does add a little bit more rigidity to everything. Also, if I do this on the short length, I can actually make this one whole piece, potentially. So rather than having this be snapping, I can actually just have this be as one piece, which is way more structurally sound. Rather than have it be connected. So I may take this and just... and just make that... and basically this would be one whole piece, so there wouldn't even be these edges over here. It'd be one whole section. So instead of having 3 and 4, this would be together. Now I do think that's going to work across the short way, because that's going to enable me to keep things... I can print that. That's only... What did we say the original dimensions were? Maybe not. We got to convert that to millimeters. Let's see. Millimeters to inches. It's a really weird measurement. It's like 25.4? Something like that. Millimeters to inches. Yeah, so 1 inch is 25.4. So it's like... so let's see. 11... now I got a 9/16 is, what is that? 9/16 is 0.5, 0.5625. So that's already 293 millimeters. If I remember correctly, that is way more than my printer will allow. Wow, that's actually... Huh. Would not have pegged that. I could try doing it on a diagonal, though. Would that even work? Because wouldn't this be... Because if this is a... Because this isn't a square. There's more this way. So I might get away with that. Hang on. Let's just test that theory out real quick. Because this is going to force us to change the design, unfortunately. Which would suck. But what are you going to do? All right, so... Let's just see if we can... Oh, I need my... Cube, come to me. Oh, why is this open here? Get out of here. Cube, I summon you to do your job. All right, so let's just say this is... X was the largest, so... Let's just make it 300. No. Not the whole thing, thank you. Turn that off. It's probably not going to work out. Maybe... Oh, okay. Barely. Oh, that's asking for trouble. I don't know. That's pretty iffy. We might be able to get that to work. Alright, so let's come back to that. I mean, the benefit here is even if we have to split this up, though, if we have another ring on top, let me change the couloir. So even if we have to do another section on top, though, oh, that's a horrible, horrible, horrible drawing. You know, as long as we have a bar going that way, and we secure it with something, we shouldn't be able to, because this bar will basically prevent us from dragging it that way. You know, so it won't separate that. And then this bar will stop us from dragging it, you know, that way. And as long as they are on top of each other, because if we have like these bars super separated, then there's a chance that it could tilt. They're going to have to stay roughly within the same area. That's interesting to me. Huh. I have no idea if that would work or not. I think it would. Bear in mind, I think we're going to make this stuff very, very thin, so it prints very quickly. I know I'm drawing it super blocky, but we're not going to make this like a super thick shelf. We're probably going to make the actual components be something like, I don't know, 10 to maybe 15 millimeters. That is way more than enough for the stuff it needs to hold. Plus, we're going to have infill on the inside, so we'll keep it from being too dense. We could probably get away with 10 millimeters just to keep everything nice and thin and as unobtrusive as possible. Maybe 15 would be a better bet, though, because I got to slide the cardboard in. So, all right, so I think we can definitely get that to work for... oh, my brain. So let's draw some posts here for a second. So I got 1, 2, 3, 4 posts. I do think the green won't be a problem going across that way. Problem is this direction here. Because this is way longer. What is... That's 23. That's almost 2 feet. So so let's just put 24 in here. That's like almost 600 millimeters. That's a lot. And since at most I can print maybe 300, I would have to at least split this up into 2 sections. So I would need some sort of joining piece. Which, I mean, we can do that. It's not a huge deal. So I'm thinking so we're going to have another section over here with a joiner piece in the middle. And the benefit with that, at least, is we could potentially... The other thing we could do to make this a little bit more interesting, so everything is flush on the bottom, because I don't want to raise this part up and then lose real estate over here, or at least not too much. I could have it so that this piece right here, the green part, is raised up a little bit, so all 4 of these lie flush. So we basically have a piece that... How would that work? It basically would do that so it lines up with the orange piece. Something like that. You know, and that's coming towards you in 3 dimensions. Like, if I draw an arrow. Oh my god, it's coming off the screen. Ha. Sorry, I'm just having fun now. So it's like, wow, wow, wow. Pew! Sorry. But yeah, so I could do that to make that flush, and then I can actually cut a piece of cardboard so that it actually goes on the bottom. That would be fine. So I think we have a rough idea. It's going to take a few parts, but I think we get that to work. I think the key here is to make them as small as possible, so it prints super fast. It's sturdy enough to do what it needs to do, and save on some material. So I think I have a rough system figured out. The question is, how tall do we want to make each section? So that's where we're going to get into some other nitty-gritty details here. Let me save this real quick, because we did some good thinking. I know a lot didn't really happen on screen, but when you're making stuff of this nature, I definitely prefer, at least from my 2 cents, is to come up with at least some sort of battle plan. You know, I could throw stuff together, but I don't want to waste the filament. You know, and particularly that stuff is in demand right now. I don't want to waste it. I don't know what I was scribbling here just a second ago. We're getting to that point, guys. So, okay. So I have to have a connection piece there. Question is, how high up do I want to go? All right. So I am horrible at gauging distances. Really bad. Like I can read a tape measure just fine, but you tell me to pick out, you know, Nick, how big do you estimate this piece of wood is? And I'd be like, I don't know, 5 feet. And you're like, dude, that's totally 3 feet. I'm like, and I get super nervous about it. So tape measure. So I'm thinking probably like, trying to think like how big I can get away with making this. Keep in mind that I'm also going to have to adhere to the actual build area. So the longest length that I have on my printer is what, the x-axis? So if I want to print multiple parts, I'm probably going to have to constrain it to the between 250 to 300 millimeters, because that is, and the other thing is I actually won't be able to fit multiple pieces of this, because now that can only print one that is that size. So I probably should make it closer to 250 to make that work. So what's 250 millimeters in inches? It's about 9 inches. So we're gonna get like that. It's not horrible. It's not horrible. But I mean, at that point, yeah, if I have a section for each area, you could argue that you might as well just make the whole thing out of PLA and then just use cardboard to fill in those slots, depending on what it is. Because then what, 9, 18... I kind of doubt I'm going to go higher than, what is it, 9, 18, 27? Sorry, I know from your view it just looked like there's a big yellow bar on the screen, but it's helping me. I doubt I'm going to go higher than 27 inches, so at most I'd have to create 3 versions of this. So that's fine. I think I'm still going to stick with this design, but then maybe just go up 2 whole levels for everything. I don't think it'd be that much material. So I think the next step I'm going to do from here is start actually designing the parts in CAD. I think I have a rough idea of what I need to do, but I just need to make sure I pay attention to my printing area, because that is going to determine how many parts I can print. And I don't want to print super large parts. It's not only going to waste material, but it's going to slow down this whole project. I want to be able to print everything in CAD. I already have done some tests with tolerances. Knock it out in like 1 or 2 prints. Like ideally, I should be able to print the shelving bits for each level in 1 print each, if not more. You know, because again, this is just a shelf. I don't want to overcomplicate it. But I don't want to make it an absolute horrible thing that when you go, it just goes. So I think we're going to just make a couple more notes here. So really the only thing I need to figure out is this kit. Are we on the eraser? What's going on here? I'm on the wrong layer. So we're going to have connection pieces here. May have to do something to fix this up because that is barely going to be long enough. I'll have to think about that as well. I don't think I'm going to be able to figure that out exactly until I start building it in CAD. But we're probably going to have to split that up, which I don't really want to do. Or I may have to still disassemble or print these separately instead of one whole part. It will be more parts, but at least I can print it all in one batch. Ideally, I don't know. I got to start modeling in CAD. So I think what I'm going to do next is, so we've got the drawing here. We've got the dimensions. I'm going to convert everything into millimeters. I think I'm actually going to reconstruct this board in CAD and then use that as a starting point. Build one of the pillars, make it modular, and then if I just build one corner, I can just duplicate that, put that on each of the posts, and then start configuring everything for the 3D printing process. So I think I've got most of this sketched out now. That did take an hour because I wasn't sure how I was going to do it, but now I at least have an idea. I hope you found that at least entertaining. I know it seemed like a lot of tedious details, but you know, for something of this nature, this isn't like where I'm like organically sculpting something and I can kind of mess around with it. I need some sort of idea before I start because it helps me out, and hopefully it gave you an idea of how you can start figuring out your own 3D printing projects. As you can see, this is no master sketch, and I blame you. The drivers were not installed, so it definitely made it a little bit tougher, but even such a rudimentary drawing can help me get my ideas across, and if I'm working with somebody, that also helps. So with that said, thank you for joining me. We're going to call that a day. In the next video, I'm actually going to start modeling this in CAD, and hopefully by the end of it, we will have some sort of prototype to go with. Hoping to have that done in the next couple days. And I ordered another webcam in the hopes that I could actually put it up near the printer so you actually see it while it's printing. However, with all the shortages right now, and obviously things have to be prioritized for certain shipping details for hospitals and all that, it might take a little bit of time. I did try running a webcam with a really long extender over there, but the signal took so long to get from the area to my computer, it just didn't even show up. So maybe I'll take some photos and show you in another post or something. I don't know. I'll figure it out. But if you have any questions or if you have any cool projects that you want to work on, maybe troubleshoot, let me know. We'll have a talk. All right, I think I'm done. All right, guys, you have a good night, and I will see you next time. Bye.